All right, guys, we're on the back side of day 4 notes. And in number 2, it says using a straight edge, draw on the vectors that connect the pre-image, which is the solid figure, to the image, which is the dashed figure. Okay, so we're going from the solid to the dashed. So we're going to go ahead and take a solid figure, vertex here, and connect it to its corresponding point that it would go to in the dashed or the image figure. Okay, this point up here, go here, and it would slide in that direction. This point here would go here and slide in that direction. This point here would go to here and slide in that direction. And this point here would go here and slide in that direction. Okay, and you guys can see that those 3 little red rays are actually vectors. And what do we know about those vectors? They're all going to be the same length, which means that they're congruent, and they're all parallel to each other. Okay. All right, in number 3, it asks us to graph triangle Amy. A is at -3, 5. Put a dot, call it A. M is at +4, +6. Put a dot, call it M. And Y is at 0, 2. Be careful with the 0. It means no left and right, and just up +2. Okay, and there's my Y. All right, we'll go ahead and try to make nice straight lines. Okay. All right, so now that we graphed our triangle, part A says to graph and state the coordinates of triangle A prime, M prime, Y prime, the image of triangle Amy under the translation T, -7, -10. So what the -7 means is that we're going 7 units, and because it's first, it's either left or right, and because it's negative, it's going to be to the left. The second number always refers to up or down, and because it's negative, we're going to go 10 down. All right, so you could take each point and slide it 7 to the left and 10 down. Or what I like to do, and I feel like you guys make a few less mistakes if you do this as well, just take that -7 and put it underneath every single x coordinate. Okay, take that -10 and put it underneath every single y coordinate. And then we're going to do some math. Okay, all right, in the very first part, we have -3 minus 7, which ends up being -10, and that's the new x coordinate for A prime. Okay, we have 5 minus 10, which is -5. Okay, next up, we have 4 minus 7, which is -3. And then we have 6 minus 10, which is -4. Okay. For y prime, we have 0 minus 7, which is -7. And then we have 2 minus 10, which is -8. And now all we have to do is graph those. So -10, -5. Put a dot, call it A prime. -3, -4. Dot, call it M prime. And then -7, -8. Put a dot, call it Y prime. Try to use some straight lines to connect your points. Okay, and there is our translated triangle. And you can see that if we look at, let's say, Y to Y prime, remember what we said, it's supposed to go 7 left and 10 down. So we can test it to make sure that it did. 1, 2, 3, 4, 5, 6, 7 to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 down. All right, and you could check each point if you want to, but each point should have slid the same amount, 7 left and 10 down. And so I think it's a little bit easier if you do that little trick there where you subtract the 7 and subtract the 10 in the same order they gave them to you in the translation. I think it's easier to get your coordinates and then graph those coordinates instead of counting 7 left and 10 down 3 times for each one and then having to figure out the coordinates after that. Okay, a little quicker. All right, so then part B says graph and state the coordinates of triangle A double prime, M double prime, Y double prime, the image of triangle Amy under the translation. So what we have to be careful is what triangle are they sliding? Are they sliding the original one, AMY, or are they sliding the one I just got, which is A prime, M prime, Y prime? And those are going to tell you, you just have to look for it. Okay, so they're actually taking the one I just got and they're sliding or translating that. Okay, how are they translating it? Well, by writing that x plus 11, remember x goes left and right, and because this is a plus 11, this is going to go 11 units to the right. Okay. That y minus 2, y goes up and down, and with a minus 2 there, you're going 2 units down. All right, but remember, we're sliding the one that we just got. And if you want to do the same trick that we did up there, all you have to do is add an 11 to underneath every x coordinate in order to make it go to the right 11. And then underneath each y coordinate, put a minus 2 in order for the y to go down 2. Okay, and then we'll just do some math. So up first, we got negative 10 plus 11. Negative 10 plus 11 is 1. Okay? And then negative 5 minus 2 is negative 7. Okay. Next up, m double prime. Negative 3 plus 11 would put us at 8. And then negative 4 minus 2 is negative 6. Okay. For y double prime, negative 7 plus 11 is 4. And negative 8 minus 2 is negative 10. And then we're going to go ahead and graph them. Okay? So positive 1, negative 7. Put a dot, call it a double prime. Okay? Positive 8, 2, 4, 5, 6, 7, 8. Negative 6, 1, 2, 3, 4, 5, 6. Okay? And put a dot, call it m double prime. And then positive 4, negative 10 is all the way at the bottom. And that's y double prime. And we'll connect, connect, connect. Okay, and you can check it again if you want to, if you're not sure that it moved the right way, but it was supposed to go 11 right and 2 down. So if we look at, let's say, m prime and m double prime, let's see if it moved 11 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to the right and 2 down. Yep, and we could check each point if we wanted to, but you should be good. All right. So just pay attention again to which triangle that they're translating in that second part. Okay. They could ask you to translate the original one, but if they did, then those primes wouldn't be here in this triangle. Or they could ask you to translate the one you just got from part A, which is what they asked us to do. Okay. All right. We'll slide down and take a look at the properties of transformations, just like we did on the reflection day. Okay. And it says, are the following properties preserved in a translation? Check all that apply. So distance preserving, is the distance between 2 points the same in the image as it was in the pre-image? So for instance, if you, let's say, look at line segment AM, is that line segment going to be the same length as this line segment, which is the same length as this line segment? Yeah, the distance between those 2 points, A and M, didn't change in any of those 3 triangles, and so we're going to say distance is preserved. Okay. In the next one, it says, is the measure of an angle in the image the same measure as it was in the pre-image? So for instance, if I figured out how many degrees were in angle M, it's going to be the same angle measurement in angle M prime. It's also going to be the same angle measurement as M double prime. Those 3 angles would all have the same number of degrees in them. So the angles did not change in the triangles, okay? And that's what keeps the triangle shape. You'll see that the triangles all had the same shape and all had the same size. And that's because these 2 properties are preserved, okay? And therefore, they call translations a rigid motion. So did the transformations preserve distance and angle measure? They did, because we checked these 2 boxes. So a translation is a type of rigid motion, just like a reflection is a type of rigid motion. You're doing a motion, such as flipping or sliding, but the triangle is staying rigid, meaning that it's staying the same shape, okay, and the same size. Okay? The angles control the shape of the triangle by keeping the angles the same. Okay? And the distance preserving keeps the triangles the same size. Okay? And when shape and size are preserved, or distance and angle measure are preserved, it's known as a rigid motion. Okay? All right, let's take a look at these last two. Number 4 says that a translation moves B, who's at 5, 4, to B prime, who's at 4, 0 now. They want to know what are the coordinates of negative 1, 2 under the same translation. Well, we got to back it up. We don't know what the translation is. Okay? So what we're going to do is we're going to write a rule for the translation looking at B and B prime. Okay? And we're going to look at the x coordinates first. And we're going to say, how does 5 get to 4? By adding and subtracting. So you would have to subtract, and you would have to subtract 1. Okay? And so now we have the first part of our translation rule written. Okay? Now what we're going to do is we're going to ask ourselves, how do we get from 4 to 0? Do we add or do we subtract? Hopefully you guys know from 4 to get to 0, you would have to subtract, and you would have to subtract 4. And so now we have the second part in our rule. And now we have the rule written, okay? So it's basically this rule is saying that if you move 1 to the left and 4 down, that's how B would get to B prime. And they want to know what are the coordinates of negative 1, 2 under the same translation. So now we're going to take our translation and we're going to apply it. So all we have to do is subtract 1 under the x and subtract 4 under the y, okay? And when we do the math, negative 1 minus 1 ends up giving us a negative 2. And 2 minus 4 gives us a negative 2. And there is our coordinate under the same translation that moved B to B prime. Okay. We're going to try it one more time. So in number 5, a translation moves P to P prime. They want to know the coordinates of 6, 7 under the same translation. So it's like a two-part question. We have to first figure out what the translation is. Okay? So we're going to look at the x coordinates first and ask ourselves, how do we get from negative 8 to negative 10? Do we add or do we subtract? Okay? Hopefully you're saying subtract, and hopefully you know that all it's going to take is to subtract 2 from negative 8. You'll end up at negative 10. So now we have the first part in our translation rule. Okay? Now we're going to go from 4 for a y coordinate to a negative 3. How do we get from 4 to negative 3? Do we add or do we subtract? Hopefully you're saying we subtract. How much do we have to subtract? If we take 4 and we subtract 7, you would move to negative 3. Okay? And so now we have the second part in our rule. Okay? Now that we have our rule, we're going to apply it so that we can move 6, 7 the same exact way, okay? Which is actually 2 to the left and 7 down. So we're going to just take the little minus 2, put it under the x, take the minus 7, put it under the y. Okay, and then we're going to do the math. 6 minus 2 is going to give us an x coordinate of 4, and 7 minus 7 is going to give us a y coordinate of 0. And there is our new point under the same translation that moved P to P prime. All right, guys. Go ahead and do your homework. And those first couple questions are just like what we did in 4 and 5. All right, guys, I will see you on the next day of notes.